Welcome, everybody, to the American Space Museum. It sure is cold in here, isn't it, Marty, over there on our Streamlabs board? So, he's just turned the heat on, so it's getting a little bit warmer in here. And I welcome you all to an edition of Staying Star Curious as I'm going to talk about backyard astronomy. Had my binoculars handy there and just come in from the outside pretending it's actually almost 70 degrees outside, but big football game tonight, and the Big Ten's looking to win with Ohio State over Texas, so we can play the Notre Dame Fighting Irish there. So let me disrobe myself here for your pleasure there, Dave Stangy, Chris Calley, and all you Michiganders out there, and make myself look pretty in my planetary vest here as planets everywhere, folks. Marty, welcome. How you doing? A Friday finally here.
I'm doing good, but since I'm retired, I have 7 Saturdays, so Friday doesn't mean much.
Every day's Friday or Saturday or whatever Marty wants them to be,
It's
but
the weekend.
that's right. That's why we're so grateful that he comes in here 5 days a week, and for over a decade has been one of the major fundraisers for us here. He's on our board of directors, but Marty also worked on the lunar module for Grumman and the space shuttle era. And I'm glad Friday's here. A lot of busy stuff and a lot of accomplishments today for Gabriel Rothblatt, our executive director, and myself. Um, and we got a lot going on. The background here is the Galileo spacecraft as it's orbiting Jupiter, though it didn't look like that. It looked different when it orbited Jupiter. The antenna didn't come out. And we're going to talk briefly about that mission and another interplanetary mission that the space shuttle took a satellite up that pioneered our thinking of another planet. But all of you have been seeing in the news, you can't escape it. 7 planets to be in the sky. Oh my gosh, you got to see it. Extra, extra. Everybody come and see the planets under your night sky. So I'm going to tell you, yep, you can see 2 of them really good tonight. And we'll be seeing those for the rest of the year, or at least through the summer or late spring. But some of them you're never going to see. You're not going to see Uranus or Neptune, all right, unless I can't even barely figure out which ones they are in my backyard telescope. You need a bigger and better scope than what I have to see them, which I got some pretty good scopes. So going to demystify that for you a little bit. Here is a slide to show you of make that big there. This is a photograph I'm going to go over in detail at the end of the show. My first and last slide will be this. This is a backyard panorama on a rare clear night in January with the first quarter moon is right there. And in this view is Venus, Saturn. Then you got Uranus, Neptune. You actually got Neptune, Uranus, Jupiter, and then Mars are all in this sky photo taken by Alex Dreyer, a very famous astrophotographer and contributor to Sky and Telescope magazine. Alan Dreyer is his name. And this is 11 panoramas, 30-degree spacing attached to Adobe Camera Raw with the ultra-wide Lao 10mm lens at 2.8 aperture for 20 seconds each, untracked, and on a Nikon Z6 3000 at ISO 800 in landscape orientation, just in case you were wanting to know. An actual picture with some graphics put on there. And we'll look at that a little bit more detail as we talk about that. You go outside, you're going to look after sunset. There's the sun, where it's set. Venus is going to be super bright. And then you turn around and you're going to see a real bright star in the east, and that's Jupiter. And then about 2 hours later, you're going to see Mars where Jupiter was. Well, let me hit my button here so I can say hello to you beautiful sky watchers out there. And listen to my voice there. Hello, Doug Forrest. Hope you're safe and sound with your wife Yoshiko there in Pasadena, California from the fires. Dean Babcock, good afternoon. Go who? I can't read what's there. It's broken up on my computer here. Huh. course, he's in Illinois. And I got your package today, Dean. Thank you so much. Sent me a package of some magazines and newspapers, and I'll thank you for that later. I didn't get a chance to do a love fest for our Stay Curious watchers today, but I promise to do that next week on there. And hello, Carlton Bailey. And he said that you saw him today, Marty.
Sure did.
Did you? All right.
Yeah, we saw him at the Julie Payette's
Did he have
autograph session, and then we
did-
went out to lunch.
Okay. Was he wearing the cat on the pizza or the cat on the dinosaur t-shirt shirt today? And I'm
one.
joking. I'm joking here. Neither one.
Yeah, get how to describe. Yeah, little things on his shirt. It wasn't anything big and bright like he normally wears.
Uh,
But
grab
he
my
can answer
picture
it.
of Julie. Would you mind swinging over there? It's under that white paper there. They were out there seeing Julie Payette. We've got a rocket launch Saturday night, Sunday morning. No, on the table in front of me there on my desk. So right under that first paper there. All right. Marty was so nice. He went out there. We saw Julie Payette yesterday, Canadian astronaut, who's just a ball to see. By the way, you're looking at Venus as it's in the sky till March. And it's going to be a big loop to loop. You see where it's at in January. It's going to get a little bit higher in the sky. But there's wonderful Julie Payette. Just one of the perks of living on the Space Coast is any day you can go out there and see an astronaut. To Mark, with warm regards, Ad Astra. And thank you, Marty, for that. That means a lot. She's great. She's going to be back here in February. So hopefully we can get her in the museum and she can check that out there. Bill Whiting says hi. Happy Friday. And Doug Forrest says they're good. Thanks for asking. He said he dressed up real nice, Carlton did, for the pretty lady out there. So we'll see you maybe over this weekend, CB. But Saturday night, Sunday morning at 1 o'clock is when this behemoth of a rocket's about to take off. I posted a picture on Facebook of what it looks like from the air with the lighthouse in it. And should have racked that up today, but just I was focusing on stargazing today. So one of those director days for me where I'm happy to be doing what I'm doing, but needed an extra hour or two today to do justice maybe to some of the Stay Curious slides I wanted to put in. Well, regardless, you're all here today. Thank you very much. All Venus and Mercury both look like this. If you could plot where they are in the evening and morning sky, they both do a loop to loop, go up and come back down. Venus in March will be passing in front of the sun and pop up in the morning sky, and then do this kind of figure loop in the morning, and then show up back again next probably November in our evening sky. So this is always a good way to show you how the planets are moving in the sky constantly. Through a telescope, Venus is about a half phase, like a half moon. It and Mercury go through phases. Now, when they talk about February 20, somewhere like that, there's going to be 7 planets visible, or maybe 8. They're throwing Mercury in there because Mercury's now in the morning sky, and it's going to pop up in the evening sky. It orbits the Earth it orbits the sun every 88 days. So take 90 into 360, all right, which is about 4. So that's a cycle of 4 orbits around in our 365 days that Mercury goes through. So twice a year it's in the morning sky, and twice a year it's in the evening sky. Want to remind you all that as you're looking around, and hope you do, and it's just so beautiful this time of year to sit out, even if it's cold, proper weather, and just watch the stars come out. Well, as you look, the sun just set behind me, and I'm out at the wildlife preserve at Merritt Island, and I'm looking to the east where the sun rises, and you see this dark band. That's the Earth's shadow that's climbing up in the sky because the sun is set. The Earth is starting to cast a shadow into space like every object does, including you. When you're walking the streets, you see your shadow. but you can see the sidewalk too. So it's like this. You're looking at the sky and the shadows there. And this pink belt has for centuries been called the belt of Venus. In fact, for millennia, the belt of Venus. And you think, well, pinkish belt of Venus, the planet? Nope. The belt of Venus originated in about 300 or so BC. So we've been talking about it for 2,000 years with the belt of Venus, the goddess Venus, which is a Greek statue of the goddess Venus in Athens. And she is about to apply a belt around her chest, also known as a brassiere in today's world. But men and women didn't wear belts because they wore tunics. So they didn't wear belts around their pants to hold their pants up. They might have a rope or belt around there for an accessory. But the true meaning of belt in Greek world was a bra. And so just the belt of Venus that is so beautiful, and I love seeing it every time, every sunset. Sometimes it's more intense than others. It's an atmospheric phenomenon of light scattering through the Earth's shadow against the brightness of the sky, and then it gets dark and disappears. So there you have it, the belt of Venus. Well, let's get on to something more serious, Mark, as if that's not. But what is this? Some monster I've created in Photoshop? No. This is clouds covering the sun and sunspots, and that is Venus. In one of the rare times that Venus passed in front of the sun, and we all got to see it in America on June 8th, 2004. 21 years ago, it's coming up with that this opportunity presented itself. Now, this was a rare event. Venus is passing in front of the sun. Like I said, it goes in March. It's going to be doing this and going up to the morning sky. But in March, it's going to be above the sun or below it, so it never passes in front of it. Mercury passes in front of the sun about once every 8 years because it's so close. Venus being farther, Mercury's about 25 million miles away from the sun. Venus is about 65. We're 93 million miles away from the sun. So these are very infrequent events, so infrequent that the next time this is going to happen, a transit, they call it, of Venus, will be in 2125. 2125. It's a 121-year cycle that Venus will, it went across in 2004, and then it went across 8 years later in 2012, but that wasn't seen from North America. This one was. And now it won't happen again until 2125 when it'll happen again 8 years apart. So I'm proud of this photo I took. Very rare photo that I'll never, ever have a chance to get again of Venus crossing the surface of the sun as the sun is setting against some tree lines with some clouds in there. What does the surface of Venus look? We don't know because there's a 30-mile thick layer of clouds around it. And it's very poisonous, and it is a hellish surface of 900 degrees. Yet the Soviet Union was very obsessed with Venus in the late 70s and 80s and landed 4 spacecraft on there that they knew wouldn't last longer than about an hour because of the pressure of all that weight of 30 miles of atmosphere. That's your barometric pressure. And the more atmosphere you stack on top of someone, the more heavy it's going to weigh down on the surface. So this is a crushing atmosphere with 900-degree temperatures from a greenhouse. This is the structure of a Venera spacecraft. That's part of the that metal there's part of the landing gear that popped off so it could activate it. And the arm on the left was something that they would pound down to tensile strength on there. You see how soft the rocks look because it's 900 degrees. It would melt lead. And the atmospheric pressure and 900 degrees, they could only build a spacecraft that would tolerate that and send back signals for about an hour. And then it overheated and was crushed like a can, like a Pepsi or Coke can. Well, we know a lot more about Venus, not just from those Venera probes. In 1990, we sent STS-30, the this crew going to not going to Venus. Wish they were. They deployed a probe from Venus. I'm going to get on my scroll here, and this was Dave Walker, Grebe, Thagard, Mary Cleve, and Mark Lee went on this mission May '89 on Atlantis, and they deployed this spacecraft, Magellan. There's the big launch there. I believe that's a Tommy Usiak, Mark Usiak photo there. If not, we'll pretend it is. And this is the spacecraft called Magellan that they deployed, okay? And it has a big radar communication disk, okay? And that's in the payload bay. Yeah, Marty, you have a question?
Yeah, Bill Whiting is asking, Mark, how long did it take for Venus to transit the sun?
Thank you for that question, Bill. It was about 5.5, 6 hours. So it was a slow process, okay? And the Mercury transit's about 2 hours. But it was an afternoon, all right. It started about seems like about noonish, and this was the setting sun of it. So, and that shows you the speed and the motion of Venus across the in its orbit. Thanks. That's a very good question, Bill. There is the payload of Magellan when it was ejected out of the payload bay of Atlantis. This is the inertial IAU inertial IAU
You
no inertial upper stage. So correct me on that, someone out there. I'm having a moment here. They started with the PAM rockets that were solid boosters, and they changed the configuration and the name to initial upper stage. I forget. Carlton, help me out there, buddy. You photographed. Carlton photographed this vehicle, I would say, probably in the White Room. One opportunity for that.
He's saying the IUS.
IUS, okay. Inertial upper stage. That's what it is. Inertial upper stage. Thank you, Carlton. Dean said his wife had the pleasure of meeting and having a nice conversation with Mary Cleve. And I believe she passed away last year.
She did.
Yep, she did. And that was kind of a shock to some of the astronaut community when I talked to them about that. Well, this is what this probe did. It orbited Venus for about 4 years and was the first spacecraft to give us a full view of the surface. And Dean Babcock says, but Mark, you said it was covered in 30 miles of cloud layer. Yep, that's why we can't see anything from Earth, but radar can dig through that clouds, and that's what they use with some radar deflection and other high-tech 21st century ways to get a view of this. This is colorized, okay, for your edification. But Venus is very flat, as you would imagine, a 900-degree place. We think this is an active volcano happening right here in the foreground and in the back. This is more of a Yellowstone Park, maybe a geyser type situation, Old Faithful. And up there is a real mound, but the mounds don't get very big because of the atmospheric pressure pushes them down and the hot weather goes there. Man will never walk on Venus, nor will we want to, but there are sweet layers in this 30-mile that they think could provide a habitat at 70 degrees Fahrenheit and an atmospheric level where there could be things living in the cloud structure like are living in the ocean, okay? Elevated in some sort of a way to just to keep them suspended up there. So, and they also found water in the clouds of Venus, but it's mostly carbon dioxide and sulfuric acid, and it rains sulfuric acid from these clouds, but it doesn't reach the surface because it evaporates beforehand. So there's a look at Venus the way we know it today. And here is half of the globe of Venus that Magellan put together thanks to that successful STS-30 deployment on there. So basically the when you're looking at this, this is not vegetation and green and deserts. This is the blue areas are the low areas, and the tan areas are high, and the green are those areas in between blue and tan, and it's all done in a computerized way to give you the features there. So very interesting. Could these dark areas have been seas? Of course they could have been. Did Venus once have water? Oceans? We don't know. Is this something that happened to Venus a billion years ago that could happen to the Earth? Uh, and we have a runaway greenhouse effect? Possibly. This is why we explore to understand these things. The whole solar system, think 5 billion years old. All right. But the oldest rocks we have on Earth are 4.5 billion years old. But it took a half a billion years for this primordial cloud orbiting the sun to turn into planets as things crashed into each other. Well, let's turn to Galileo Galilei. Let me have a little swig here of Tang on a Friday. Ah, not too bad. Or I'm getting accustomed to it, Marty. so, um, Galileo. You can't get any more important than Galileo and the first time that he saw the moons of Jupiter taken like you would see them through in binoculars. If you could hold a binocular still, and there's devices for that we've talked about. Until 1610, January 6th, we thought everything orbited the Earth. The sun, the moon, the stars, the planets, everything, the 5 planets that moved, they didn't know exactly what they were, but they knew there was 5 objects that were unlike the fixed stars that moved around, and that was Mercury, Venus, Mars, Jupiter, and Saturn. Uranus, Neptune, and Pluto couldn't be seen naked eye, though Uranus can, but they never discovered it moving around the sky, but it's very faint to the naked eye. So it was on June 10th that he first discovered the fourth moon. He saw 3 on June 6th. June is cloudy. June 7th, June 8th, they had moved. He couldn't believe it. June 9th, the 3 moved again, and June 10th, one of them popped out from behind the planet. So Galileo knew at that moment that other things orbited the planet Jupiter, and that our solar system, we had to orbit the sun like Copernicus thought 50 years later and was too afraid to say, because the dogma of the day was established by an Arabic astronomer named Ptolemy, Ptolemy, Ptolemy. And the Ptolemy were a big group of influencers, a family that were in held court for years, decades, centuries. So anyway, 2,000 years of stigma was disproved by Galileo's telescope pointing at the sky. Here he is showing Pope Urban, supposedly, who he made fun of in a play that was he. I actually got him and his beliefs under house arrest the last 10 years of his life. Read about Galileo. A good book is Galileo's Daughter, which is the letters of his nun daughter to him, or letters to him to his daughter, because the ones to when he was in house arrest have never come up again. So, Steve Jokums joining late today. Thank you, buddy, for being here today. Probably got some snow. I saw a bunch of snow in Memphis where my daughter is. They got about 3 or 4 inches, Marty. But here's a picture. You got cardinals behind. This is Pope Urban showing him. This is not how you look out stargazing from some parlor looking out the window, but that's the representation that was given to this historic event. There you see the belts and bands of Jupiter that Galileo could see. The other photo was overexposed to show the moons a little better. There's 4 moons there. And in your small telescope, you can watch them rotate around. Yes, Marty.
Mark, do you know how far the moons are from the surface of
Great
Jupiter?
question, Marty. I can only make a guess at this moment without something in front of me. Uh, the closest moon is Io, and it has 200 volcanoes of sulfur emitting from it. Well, we're going to look at that in a minute. Uh, but yes, they are about on the order of Io. I think is as close as maybe 50,000 miles. But the scale here, all the way out here, is about 1,000,000 miles. I think it's about a scale of about close 50,000, and the furthest away are about 1,000,000 miles away. And these four moons of Jupiter are the largest, and Ganymedes the largest in the solar system. There's a picture of Jupiter that many backyard astronomers are taking of the cloud bands that we see. We don't know if Jupiter, Saturn, Uranus, Neptune actually have a solid surface. We think they have a rocky core by the way they react and how planets have analyzed them. But these cloud belts are influenced by the sun's radiation. Also, there's internal heat coming out of these planets from a source inside. And there's also Jupiter has a hellacious magnetic field. It's very rarefied, it's invisible to us, but very influential to things going on there. Wait. Oh yeah, okay. We're going to talk about those moons here in a little bit more detail. And we know what these moons look like because of this mission, STS 34. And I think I know the date right, but I'm not going to utter it because Steve Jokums is on the line here. Yep, October 89. So May 89, we went to Magellan, and October 89, Atlantis again made its fifth trip right after deploying Magellan. They deployed the Galileo spacecraft named after him. And as you see, it looks there's the rocket launch. Beautiful, beautiful launch there. Thank you, Tom Usiak, for letting us share these pictures. And there again is a very similar looking spacecraft. The deployment, IUA, IUS, I mean, is the same. The yoke and everything that held it in there at the bottom during the ascent to orbit is the same. And and it has the big radar dish there that is supposed to deploy up at the top that you don't see. It's folded up. But when they unfolded it, it didn't unfold all the way. I wanted to look at something here. The Atlantis and I'm thinking that also. Oh yeah, I want to see how long they were up there. Yeah, these were all quick 5-day missions. All right, basically get up there, deploy the satellite in the first or second day, and then do a few biomedical experiments on the astronauts, maybe a couple experiments, and then get back down to Earth. So this is our good buddy um, Mike McCulley. All right, Bill Williams was the commander. Shannon Lucid, uh, Baker. That's Ellen Baker, not Mike Baker. Mike was a pilot or commander, and our friend Norm Thagard, Marty, was on this mission also. I think Norm was on there. Am I wrong? Wait, let me go back. No, Chang Diaz was. Yeah, when I said that, Steve Jokums, I knew I was wrong because Norm was on the Magellan mission on there. Norm's going to be out at the Space Center next week, I think. We have Jose Hernandez coming up next if you're coming to town. So that was deployed. This is what it was supposed to look like, but the antenna did not unfold properly and jammed. So they had to use one of the other smaller antennas on it, this one that you see there, to relay all the information, or they could have even gotten higher resolution pictures back. But Galileo worked for over 12 years, and they did a kamikaze dive into the Jupiter so that it wouldn't accidentally hit any of the moons and pollute them. Now, as it was taking pictures this close of Jupiter, you see that moon up at the top is probably Io, I'm going to guess, and you see its shadow on Jupiter, and the one at the bottom is Callisto, I think, and you see its shadow on Jupiter there. Okay. And one night, Marty, you can see this in a telescope, in a backyard telescope. You can see not the moons, the planet's too bright, but you can see that it washes out the moon, but the shadows there. And one night, a friend of mine who's very smart. We figured out by the size of the shadow, we could figure out some cosine trigonometry stuff of how large that shadow was, because we knew the size of the moon and we knew its distance from Jupiter. Good question. I'm going to look up these distances of these moons. Here is the best view of the moons from the Hubble telescope. All right, which we got now. Of course, these images of the Hubble deployed in 1990. All right, this was early stuff to compare what they saw from Galileo. So Io is very small. It's the size, not very small. It's the size of our Earth, of our moon. Io's the size of our moon. Europa's about a little bigger. Callisto is still bigger, and Ganymede is the size of Mercury. And this is what the Galileo spacecraft showed us of these. Io, the closest one, is tortured, like rubbing your hands, or a rubber ball that's kept rubbing back and forth is going to have heat, and its guts are being pulled out of it by the great, tremendous gravity of Jupiter. And then you see Europa. I mean, yeah, that's Europa, Ganymede, and Callisto. Ganymede's the middle, and Callisto's over here. Europa's the one that we're sending a spacecraft to, called Europa. Your European Space Agency is. Those stripes there are fissures in the ice. That's all three of these other ones. They are cold moons with lots of impacts, but look at how the surface has been resurfaced. You don't see many craters on the second moon there, Europa, because the surface is constantly being regenerated, just like Earth's meteors have been eroded by the atmosphere. Go ahead, Marty, on that UCX family microphone.
Yeah, Mark, each moon looks significantly different. So, were the moons captured by the gravity of Jupiter, or did it come from Jupiter like our moon came from Earth?
Great question. We're not sure even if our moon was captured, but we're pretty sure it was not.
Right.
Some of these were, no. We think these, the short answer is these formed nearby Jupiter as Jupiter was coalescing into this gaseous giant. That Jupiter's so big, Marty, that every planet, every moon of those planets can fit inside of Jupiter, and it still has about a third of its volume left. If Jupiter is 1/10 the size of our sun. If it was 1/4 the size of our sun, it would have had enough gravity to have fission created, and it would be a star. Where we think we're looking at Jupiter, we're looking at a failed star. But then all of the debris that coalesced out of the early primordial cloud start smashing into each other. There's a point where they reach a certain size and gravity makes them a sphere. So yes, we think all these were created there. Now there's about 80 moons orbiting Jupiter, and over half of those are under 100 miles in diameter. And yes, many of those are captured asteroids or through the solar system. Now, Jupiter is so big that before it and after it are what are called the Trojan asteroids. And in a sense, they're kind of moons that don't move around it, but are pushed around or dragged behind it. And we are going there to visit some of those Trojan asteroids by the spacecraft called Lucy. Remember Lucy being launched a while back on the Falcon Heavy, I think? Well, Lucy's headed to those places there. So Jupiter is so interesting. And we're going, right now we have a Juno spacecraft that is orbiting it. It's going out to a couple million miles, and then it's coming back down and dive bombing as close as it can get to Jupiter to get some tremendous pictures. The pictures of Jupiter's clouds, Marty, look like a Van Gogh surreal painting. They really do. And if you want to entertain yourself, go to NASA Jet Propulsion Lab planet images, or just Google Cassini was a spacecraft that went to Saturn, or Galileo. Google some of those images, and or go to Juno and you'll see it looks like a watercolor. It just looks like somebody threw a bunch of oil and colors together. It's just amazing. But this is a very, very dynamic world with electricity and stuff like that going on. So before I leave Jupiter, just wanted to emphasize that yes, that is the brightest star. When you look to the east, looking for the belt of Venus, when the belt of Venus disappears, Jupiter will be bright through that twilight to see it, and then when it gets dark, you will just look and see it. All right, just like you see Venus, you can't miss it. Near Venus is Saturn. All right, we'll talk about that here in just another minute. So we've got a full moon on the 13th. It's called the cold moon. Duh. Most Native Americans were shivering anyway, but the January moon, December's cold moon. I'm sorry. The January full moon is called the wolf moon. We talked about that. It gets that connotation because wolves were baying in the night because they were starving. They were hungry. And so that becomes the name of it. I've shown pictures like this before. We have a lot of warm weather, a lot of cold weather across our country. That inversion layer creates certain kinds of ice crystals in the atmosphere that create a ring around the moon and even the sun. Okay. And this ring around the moon is 22.5 degrees on one side. So it's 45 degrees diameter. And it's very interesting to see and a photograph, very easy to photograph. So go out and check that out. So this was January 1st, 2025, this year, but this is also January 10th or January 30th. You go out after midnight. Orion the Hunter is going to be right there. See the 3 stars of the belt and the 2 bright stars, for one for his shoulder, one for his knee. Sirius, the brightest star in the sky, is up. But you're going to see how it pales in brightness compared to Jupiter and even Mars. That's going to be Mars directly overhead. About an hour and a half after Jupiter's, you'll see Mars in that same location up there. So get out and do your little stargazing. Get you a planisphere, like I'm reaching over here to grab. A night sky in your hands, or have an app. Those of you all have apps, I know, on your phone, and that will show you exactly where the stars are. This, you set the date and time, and you see what's up in the sky. All right. And astronomy, it's not like just flipping on the TV and watching a rerun. No, you've got to kind of, let your eyes get dark adapted. So just like you do when you go to bed, you flip out the light, you don't see anything in the room. 10 minutes later, as you're dozing off, you see all the knickknacks on the shelves there. Your eye opens up, that pupil, and lets more light in. Allow yourself that time out there, and you're going to be amazed what you see, because out there is what we call the winner's circle, and this circlet. And these are all bright stars in the sky. And there you have Jupiter. Capella is a beautifully bright star. Jupiter is actually closer to Capella. This is last year's picture of it. Castor and Pollux are 2 stars that are right above Mars. You're going to see Mars nice and red. Castor and Pollux are 2 stars above that in Gemini the Twins. All right. You've got Taurus the Bull. Aldebaran is the eye of the bull over there. So a lot of prominent constellations of astrology are up right now. So Sirius is the one on the bottom there. Procyon. Sirius is in the big dog. Procyon's in the little dog. All right. So you can imagine. And this is the time of year where there's no time of year where there's more bright stars like out today, in the next 2 months, 3 months. All right. We'll end by just showing you here this panorama by Alan Dreyer. This is actually his home up in Canada, up there, taken on, I think he said January. Oh, let me get down here. I think he took it January 1st. No, clear night in this month. Well, it was like last first quarter moon was Wednesday or Tuesday. So in February, Venus will pop up here. I mean, Jupiter, Mars. Mercury. All right, I'll get it right. Mercury will be just below Venus, then Saturn. All right, and Venus is getting closer and closer to Saturn. Notice the line there, Marty, the curve. That's the ecliptic. This is the beauty of going out and seeing 7 planets at one time, is that they're all lined up in a row because they're always seen in the ecliptic, the 12.5 degree belt wide that goes around the circumference of the celestial sphere. And because of how we're inclined at 24 degrees and the sun and all this stuff, you'll never see Jupiter. You'll never see Venus up by the Big Dipper. Or all right, you'll never see the moon further north than directly overhead. All right, the planets and the moon will always be looking south. All right, not looking north. So this is looking south, and you get the idea. And here's Neptune. Neptune's near Saturn. You'll never see it. If you find a star chart, it'll show you where it's at, and you can find it. It's very challenging, even in a backyard telescope. All right. And that's in Pisces. And then you've got Uranus is not too far from Jupiter. It's actually near the Pleiades, the 7 little sisters that we talked about on a Stay Star Curious. And then you got Uranus, Jupiter. All right, it's near Aldebaran, easy to see. Mars is easy to see. Okay. So they got Uranus and Neptune, like you're going to see them, you're not. All right. It's just you're going to see Mercury, Venus, Saturn, Jupiter, and Mars, the 5 classical planets, which you can see. But yes, Uranus and Neptune will be up there. All right. And the 8th planet, Pluto, is in the morning sky. I mean, not the 8th planet, Pluto. I think it's the 9th planet, Pluto. I was saying, what are we missing there? Mercury, Venus. Oh, Earth. Yeah. Duh. I'm going, what? There's 9 planets, Marty. How come we can only see 7?
8 planets.
Because the Earth is one of them. And the 8th one is Pluto. So, thank you all for watching today. I know Dave Stengy's already crying because there's cloudy skies up there and in Illinois where Dean's at. And Ace Boogie Stacks, thank you for watching. Yep, he's in an area where there's a lot of rain. That's why I didn't want to live and work up in Cleveland when I had a chance to, was because I know you're lucky to see a clear night 5 times in the whole winter, and that's just the nature of living on the Great Lakes up there. They generate a lot of clouds through the moisture coming up there. So, Marty, thank you so much for doing today. You got a question as I thank Dean and Doug Forrest, Carlton, Bill Whiting, Steve Jokums. Hello, John Borelli up there in Limestone, New York. Dave Stange up in Macomb, Michigan. And Ace Boogie Stacks, wherever you are watching. And hello, Hazel Banks and Sharon Rodriguez. Thank you for watching today, ladies. Marty, your question.
Yeah, Dean Babcock is asking, what is the distance of Mars from the Earth right now?
It is about 50 million miles. All right. Good question. It is about 50 million miles. I have an app for that, but the closest Mars ever got to Earth was 35,000 miles. That was the year 2000, I think. And we had Mars parties all over every cocktail lounge in Upper East Tennessee because everyone wanted to see Mars. But that's close that ever came in human history. It is not that close of a, they call it an opposition with Earth, but it's 45, 50 million miles away. So, but you can see it in a telescope, the disk, and you can see the white polar cap. And that is the next 2 months will be the opportunity to see that, though. Great question, Dean. And Jupiter is about somewhere probably about 300 million miles from us. All right, if maybe 400 million. Let's say Mars is 45 million miles away, and Jupiter's about 400 million miles away from us. So great. Thank you all for watching today. And as usual, we appreciate you being here on Stay Curious with your questions and so forth. Monday, we're going to have this guy, Nick Thomas, on. Nick is going to talk about the NASA administrator to be, Jared Isaacman. He wants to talk about them there. Keith Tyler says hello. Hello, Keith. Keith is 92 years old. Hey, Keith, glad you found YouTube. I sent you the. Go look up Keith Tyler there. You see his name. He talked about what was he involved with? Keith, I'm embarrassed. Which you're the crawler in some way, I think.
I forget.
But Keith is a great talk on there, and he's in his 90s. Thank you, sir, for watching. Please stay healthy. Nick Thomas is going to talk about NASA administrators, particularly Jared Isaacman, which he's talked to several astronauts to get their take on it. So stay curious and check that out with us on Monday as we come back to you at 4 o'clock. So until then, of course, I got to say, go Buckeyes, all right? As we hope that though we can't beat Michigan, we will beat Texas and then hopefully Notre Dame for the national championship. Sorry, Mike Baker. We should have gotten a better education than University of Texas, Mike, one of our friends. And I'm going to send Bakes a text to tease him about tonight's game. So thank you all for watching. Go back and watch some of our old shows. Look up Keith Tyler. He did a great job, and it was fascinating with his career with out the American space program. So until Monday, you all have a safe and healthy weekend. I'm Mark Marquette saying I can't wait to see you under the stars to bridge the space between us. All right.